This is Hallicrafters Rehabs. Welcome back. This is basically just a continuation of the same video in the second part. Laptop is still in Texas, won't arrive till tomorrow. This is Sunday. And so we're going to start working on these sub-chassis, like this notch filter sub-chassis. It's like a tower that sits on top of the chassis, and it's pretty simple inside. Or if you're a Knights of Catan fan, it's a Metropolis piece. I don't know if anybody knows what I'm talking about there, but anyway. So I'm just going to go through. I've got the components listed here on the left, and we're just going to go down and do the measurements. It looks like I've replaced not only already the capacitor and two resistors that were fat Allen Bradleys with these Vishay technology metal film 2-watt resistors. It's a nice little package. But we'll go through and check everything and take measurements as well and make sure everything is as expected. So we'll do that off camera, but we're just continuing on with the checking and correcting. I have no idea where the shield is on that shielded lead is on that capacitor, and I know I didn't do a lot of resistance checking, so we'll get that done as well. Well, almost the first thing that I did, just about the first thing, was I was removing the filament wire from here to put in a nice long piece. And I don't know if this is clear enough to see. I'll take an iPhone photo that this pin popped right out, corroded. I sure hope that's not a trend. And out it came. So I put on order not one but two of these 7-pin tube sockets, and hopefully I won't have another problem like this one, but I have at least a spare in case it does. So I've done everything I can do with this until I get the parts in, but it's ready to go with a new tube socket. All of the measurements have been done. The resistors all checked out, except for this 1K resistor that goes to the cathode of the tube, and I replaced that. But all of the capacitors were good, and this will be ready to go. This is a 1 meg, looks like a half-watt maybe, that's used in the, off the grid, and it's going to be okay, so I'll put it back in. So we'll move on to the mixer box. Okay, so I've got the second IF mixer box here, pretty cruddy looking in places. We'll be cleaning that up, and then we're going to be going inside and see what we have. So this is the filament lead. That's the black and the white on the schematic. This is the output signal. That's the input signal. The red B+, the blue plate, the green, and the yellow to the power switch. It will be keeping to that color code First thing you do is you take the bottom off. This has not been done before in this receiver. I hope I won't have to do it 5 times like I did, because I miswired it and stuff. It happens. Socket wrenches are getting kind of warm. Okay, so this slides out. Okay. It looks like a little better quality 0.01 microfarad capacitors in the Mark I. However, when they changed this to a different kind of ceramic capacitor, which is nice. This looks cooked, not surprising. That resistor. And there's a whole bunch of 100,000 ohm resistors in here. So this is yellow. This is the yellow lead to the power switch. This is the green lead to the power switch. This is the white. That's the black. That's the output. We're going to be replacing blue, okay, and it goes to a plate, and this goes to B+. There's the filter. We're going to be replacing these. They're really almost like RF antenna transmission coax. Good coffee. And I've got replacement shielded. This is 20 AWG. I might have used maybe 18, but 20 will be fine. It's single conductor. When you're looking for it, single conductor, or 1C or 1 CONG shielded. And DigiKey was the only one that had it in small quantities by the foot. I had to buy 100 feet from Mouser, and it'll be a long time before I can use 100 feet of that. So I see they've increased this resistor to 1 watt, and it's a little bit cooked, so we'll be probably putting in 2 watt. Okay. So got some cleanup on the inside. We'll probably be able to remove this. Should come out pretty easy. This larger one, then we can clean back behind here. These are a little more tricky, but I may have to get in there anyway just to check that resistor. There's a resistor down in there, and probably have to replace it anyway. So, and I found myself, these are the crystals right here. One is 1600 and one 1700 kilohertz. I found myself just going ahead and replacing these 100,000 ohm resistors just because I was there. Okay, so disassembly continues. Okay, so one thing leads to another, and there were resistors out of tolerance, particularly this a 2200 resistor is around here somewhere. This 100 picofarad ceramic capacitor was toast. One resistor was actually changed color. It was so in such bad shape. I believe it's right here. Yeah, that's on T3. That's supposed to be a 22,000. If you can figure that out, resistor. So might as well just go back to here. We got a lot of cleaning anyway. Can get back here and get it cleaned the way it's supposed to be, and here's an example of prepping the filament lead right there. So this is, next stage is I'm just going to clean this for a while and move on from there. Okay, well, I've been busy working on this box. I may have had the battery die on the microphone, so I'll repeat some of this information. I did started checking components, and here's a ceramic 100 picofarad that was just broken in half. This resistor right here is well, it's toast. It's supposed to be 2200 and it's brown. So either that's a wrong value or that's cooked, and so forth. So once you get started, you just keep on going. So we've been working, removed all the components in here and worked my way back this way. Now we're going to rebuild starting in the crystal area right here and then go back in the same directions. This is the T9, this is T4, and this is T3. And also took the time to go through and cleaning and polishing up the box. So that's where I'm at, and we'll keep on trucking. So it's many hours and a couple of days later that I have reassembled the mixer box. Let me say again, this resistor was a 22K resistor. It's turned black and it's shorted, and it was the screen voltage for the 6BA6 mixer, which meant that the voltage to that tube was up at close to 200 volts, which is 100 volts more than it should be, which turns that tube on substantially, and probably is the reason why this 100 picofarad capacitor looks like there's nothing on the inside. It just cracked open up, and this 120K resistor is open. So hate to say it, you know, when I first did the recap on this receiver, I did not want to go into the box. I was afraid to, you know. All I knew was to replace components until it started working. I was just servicing it and not really knowing what I was doing 3 years ago. But you do have to get inside these sub-chassis of the receiver, no matter how complex it is, because of stuff like this that you're going to find. There were a couple of 100,000 ohm resistors that were like 50% out and things like that. So you got to get in there. So as you saw, I began removed all the connections to this tube socket first, and then I worked around to this T3, which is right here. You really can't see it too well. It's buried under this strip, which I bend back. Don't do this a lot, okay? But you can bend it back, and you desolder these chokes very carefully, because I've damaged them before. Repaired it, but you just don't want to do it. Then you'll have access inside here to T3, and you detach the connections there, remove the components. There's T4 is buried under here. These mica capacitors tested out just fine, so they're back in there. You pull those out, Then you get to the crystal here, and it's just packed into place with leads that go to the ground and to two terminals for this 12AT7 dual triode tubes socket. There's two on each side of the crystal. There's 100,000 ohm and a 0.01 capacitor in parallel to ground. And these are multi-layer ceramic capacitors, high voltage, and are extremely stable to temperature capacitors. So I found some of these and put them in both cases. There's one packed under this choke with its 100,000 ohm resistor. There's also one here that replaced a 0.01. This is what came out of it. They're probably okay. I didn't even test them, but if you're going to open this thing up, these were okay too. It's easier just to take them out. They're easy replacements. These are higher quality anyway. And you're going to redo this box. Take out these IF transformers carefully, and when you put them back in, the screws, don't torque it too much, or you can actually rip the connection of the screw to the aluminum outer box, because that aluminum outer box is very thin aluminum. So just a little bit more than finger tight for these screws. What else? I kept the color scheme of the schematic. Red is B+, this is the filament, blue is the plate, green goes to, and yellow go to the power switch, and the black and the white go to the sensitivity switch, and actually in the set that's more like a yellow, but anyway, so that's in there. I could probably put a little bit of insulation there before we finish up. And then this is the output, and this is the input. Notice these are substantially smaller, but still it's functionally identically very good quality, 80 degrees C, 300 volt. You won't have any issues with those because it's going into screens anyway on tube. So that's took a lot of time. Did get it polished up. Another aspect, you know, when that 6BA6, it's amazing the receiver actually worked. Okay, I can't get a light down in there. There we are. I'll just use my flashlight here. Okay, that's a 6BA6 mixer tube location. Consider it was at, screen was at 200 volts, and you had these components, you know, cooking away or not doing anything. And, you know, difficult service. We'll have to really test those 6BA6s to make sure they're still okay. And it's a shielded, this is a pretty confined space for a tube, but with it polished like this, I'm hoping that the heat removal effect of this box will be improved over just, you know, any kind of oxidation is like insulating material. So anyway, this box is ready to go in. I did test as much as I could, and I went through whenever you do this, you go through and you make sure there aren't any inadvertent shorts. Everything's good and tight. All the pins on every tube have separation. There's not a solder ball somewhere. All that kind of stuff you want to go through and inspect. And then I did some DC resistance checks, and they seem to come out all right, as best you can do with nothing connected. But I will actually test this again inside the set with these just tacked into place, just to see if the resistance DC checks are what they should be. So that one's done, and we're still waiting on parts on the notch filter parts are supposed to come today, so it's a pretty quick job. I don't know what I did with the notch filter box, but it's a pretty big, quick job to put the tube socket in there. We can test that and then close this up. We can test it, put the socket in, test it, and then close it back up and put it on the chassis. And that's enough. Back later. Okay, so the parts didn't come for the notch filter assembly. And so this is as far as we can go this week, and it's time for me to go visit my father and see how he's doing tomorrow. And that will wrap it for this week's video. I did put 2 screws in the mixer box, and you just slowly feed the cables through the available holes, and we'll worry about attaching that and testing that a little later. So this is Hallicrafters Rehabs. Thanks for the new subscribers, and thanks for watching.